So, in order to convert our design into an actual insole or an orthotic, the computer-aided manufacture part of the software has to be used. Also, we need to choose our material that we are going to use for our orthosis. Now, there are a huge variety of materials, most common being EVA for CAD/CAM. However, there are also plastics. There are blocks of plastics that can be used to form our orthosis. EVA hardness is determined using what is known as Shore. This Shore hardness gives us a quantity of the density and how hard our insole is going to be. So you can have material which is quite soft. This is a Shore of 25, which is quite soft. What we call medium density. EVA has a Shore of 50, while this is a double type of material. So this has a medium Shore in the back and the lower Shore in the frontal part. As we can see here, this is a 50 and 30 Shore kind of blank, which we are going to use for our own this particular patient. There are also different types of materials where the divisions between one material and the other is going to be used. Also, there is a tri laminate, what we might call tri-laminate, 3 layers of EVA of different densities and hardnesses. So this is an important component of the CAD/CAM system. It is the actual milling machine, which will be used to remove material from our blanks in order to form the insole or orthotic. It is mainly composed of a tray that is going to move, also a head, a router which rotates, and as it rotates, the drill cuts across the material. There is also a vacuum unit here and a brush so that it will extract the dust that will come off when it is cutting in the cutting process. Since it is enclosed, there will be no dust, so it is very safe to use. I have already loaded the 2 blanks here, so all I need to do is just close the machine and switch the machine on. So these are the finished orthoses which we need to remove from the milling machine. As we can see, there is minimum number of amount of dust, and the finished orthoses can be seen. All it needs is to remove it from the blank now. For this patient, we have decided to use a Ude plantar cover instead of a plantar metatarsal pad, because some research that we have conducted, which is published in the Journal of the American Podiatric Medical Association, has shown us that the effectiveness of a plantar metatarsal pad might be very limited. In fact, in this study, in which we assessed the effectiveness of the various types of padding to reduce forefoot pressure, we concluded that the plantar metatarsal pad was not really so effective in reducing this pressure. And the results, as I can show you from this drawing here, is quite
obvious now because during the propulsive phase of the gait cycle, the plantar metatarsal padding can be easily seen to be in a position in which the metatarsal heads are not being pushed up as we had originally thought. So in order for this type of padding to be effective, the patient has to walk with a type of shuffling gait, or what we might call an apropulsive gait, which lacks a propulsive phase of the gait cycle. Our patient is clearly not so, and so we have decided to use a UD plantar cover instead of a plantar metatarsal pad, or a PMP.
Before printing the 3D object, again referring to the insole in this case, this is put into what is known as slicing software, and the slicing software will allow us to control how the insole is printed. Here we can see the insole on the 3D printer, and I can look at the various layers that make up this insole as I have already predetermined and set it. I can see that this is composed of 130 layers of about 0.2 millimeters each, and I go slowly up. I can see each layer being built, and layer by layer I can see that the insole is being formed until the last layer. Once this is saved, here actually I can see the support material which I have referred to in the previous video. Once this is finished, we can export this a file called G-code, and in the G-code there are the instructions for the 3D printer as to which layer and how much material and where to go, etc. once it is slowly building the 3D object.